Hey, Chem team. So you guys saw in class today that there's a couple of ways to speed up the rate at which a solute is dissolved by a solvent. One way is by increasing the temperature. Because when a solvent gets heated up, its particles move faster, that means in a hotter mixture, there will be more collisions between the solvent particles and the solute particles, which allows the solute to get broken up faster. Whereas in a cold mixture, the solvent particles are moving slower, and so they collide with the solute less, and it takes longer for the solute to dissolve. Likewise, stirring a mixture will cause the solute to dissolve faster, because stirring forces the solute and solvent particles to collide with each other, breaking apart the solute. And last, the dissolution rate can be increased by crushing up the solute into a powder. And the reason behind this is that a solute, when it's crushed, has more surface area exposed to solvent particles. So if we come over here to the model where we see a solute that has not been crushed, you can see that all of the solute on the outer edge of this ionic crystal could be dissolved by the solvent. The solvent has access to these edge particles and could dissolve them. However, on the inside, this solute is not being exposed to the solvent. The solvent can't access this inside, and so these inside solute particles couldn't be broken down yet. Whereas when the solute has been crushed, all sides of the solute are exposed to the solvent. There's more surface area exposed to the solvent, and so it can be dissolved easily. So what all these changes have in common just rests on the fact that the solvent particles need to be able to hit and attract into the solute particles in order to dissolve them. And so any sort of change that increases collisions between the solvent and the solute will increase and speed up the rate of dissolution. And that's it. At this point, you guys have a couple of practice problems. We'll see you in class tomorrow.